Analog thoughts.
Analog thoughts.
Analog thoughts.
Analog thoughts. Analog thoughts.
Analog thoughts.
Trees and fungus and hope. I've got here on my notes, just talk about life for a little bit and what has been going on in my life. I went on a really nice hike with a group of people the other day. That was really, really fun. We walked down by the edge of this river and just talked, and it was a bunch of people that I had not really met before, that a friend of mine, he coordinated this meetup. So we all got to talk and exchange, and it was a lot of fun. Today, I officially tore down the last bit of the garden I was talking about on the last episode. It's just that time. You know, we had a plot at the community, the South Park Urban Garden, and today was the final day. I took a blade to all of the tomato plant remnants and put everything in the compost and just finished cleaning up shop out there. It's the end of the season, end of the harvest season. Hung out with my mom and my sister and my son yesterday. That was really nice. Had a nice dinner and played some games. Tons of fun. Working on writing, working on coming up with new ideas and new plot points and things to incorporate into this story, into this book that I'm writing. It's been a lot of fun. I think the thing that got me thinking about today's topic was just going out on a handful of hikes recently. Not just the one I mentioned, but I've been going out on hikes pretty frequently lately. And I've been thinking about trees, and I've been thinking about how the seasons are changing and how all these plants are interacting and how all of these natural systems are existing behind the things I can see, how there are all these chemicals and all these like bioelectrical signals getting transferred among all of the plants. And so I wanted to do an episode that was kind of themed around that thought. And I actually learned a lot. I knew that there were networks of fungus that were connecting a lot of things in forests and a lot of plant life, but in researching stuff today, I learned, not that I don't usually learn a lot from the things that I research for these episodes, but it was cool to learn some of these facts today. Before I officially get started on today's episode, I just want to give all the patrons a shout out. Thank you for supporting me over there. If you'd like to become a patron, there's a link in the show's notes. To everyone supporting me over there, thank you, thank you, thank you so much. Okay, so even beyond being inspired with these recent hikes, this is actually kind of a topic that I've had on a list that I've wanted to dive into a little bit for a long time now, because I think it's pretty fascinating. There are chemical, electrical, and dare I say spiritual languages going on between different plants. This magic exists between the dirt and the bark and the cells and the moss, and the stretches between various networks of plants. Just like human language, these plants have a language of their own that has been evolving and changing over time for a very, very long time, longer than humans have even been around, for much longer than that. And for today's episode, I'm going to primarily be focusing, like the title suggests, on trees, and I'm going to touch on a couple other plants, but I'm going to kind of zero in on trees and how their networks exist amongst each other. Right now, Earth is home to around 3 trillion trees, and there are over 60,000 species of trees. And like us, like humans, you can find trees on every continent except Antarctica. And as humans, sometimes I feel like we can see trees as these delicate, vulnerable things because of their inability to migrate when the climate around them changes, or their inability to ward things off or protect themselves. But it's that very thing, their inability to get up and leave, that has made them some of the most resilient and strongest things on Earth. They've been around for close to 400 million years, and they have survived all of the mass extinction events that have happened on Earth. So if that's not tough, I don't know what is. Trees are one of the reasons humans can exist at all on Earth. They make oxygen out of carbon dioxide. They make usable soil for farming, and they're a big reason our planet is even habitable by anything in the first place. They make their own food supply just from sunlight and water. It's pretty crazy. And if only humans could take notes from trees and figure out how to make their food from the sun and water. That would be the trippiest thing if we could, as humans, just photosynthesize. Like, no, I'm good. I don't need to eat. I'm fine. I'm just hanging out in the sun and getting everything I need. And as you'll learn as this podcast goes, there are other factors that are feeding them nutrients, and they're getting things from the soil directly and indirectly. They're not just relying on the sun, but the main portion of their energy is from photosynthesis and creating these sugars that fuel them from the sunlight. And not only this, trees can live for literally thousands of years, which as a human, I wouldn't want that for humans, or at least me personally. I wouldn't want to live for 1,000 years, although I would like to see where we're inevitably going to end up as a species. I would like to see what Earth looks like in 1,000 years or thousands of years, but I don't necessarily want to live through all of those years. That would be just too much. For a long time, scientists thought trees mostly were working in this singular way, like survival of the fittest, competing for sunlight and clawing their way to the top of the forest, leaving the weaker, smaller trees in the dust. But there has been a lot of research that proves that this is not the case. These trees, the trees on Earth, are working together. They're cooperating. And there are a lot of ways that scientists have figured this out. A lot of experiments have been done. But one of the biggest ways that scientists have figured this out is by looking down to the roots, getting to the root of the situation. And that's where the communication is happening in the root systems. Not only do trees speak to each other through the roots, they use their interconnected root systems to pass on resources, warnings, and they pass down information from generation to generation for survival, just like humans do. Trees talk to each other. And this communication allows forests to thrive and work as a singular organism. And we could really learn a lot from the way that trees function and communicate. And we have as humans. We work together. It's one of the big reasons we've survived. We became tribal, then we became farming communities, and then we worked together and shared technologies. And I think we've lost a small essence of that we could regain by studying plants and trees and looking at how they're thriving by working together. And there are all of these symbiotic and mutual relationships on Earth with animals and plants. Think of like bees and flowers and fish and anemones. Countless relationships that allow for a mutual benefit between different organisms, between different animals and plants, and between different plants and fungus. And in modern plant science, scientists are really just beginning to understand the relationship that trees have with each other and how they communicate with the fungal network in the soil. And I'm going to break all this down, but it kind of started with this German botanist in 1885. His name was Albert Bernhard Frank, and he suggested this. He suggested that plants and fungus were talking to each other in the soil. And like many scientists throughout time that presented wild, new ideas, he was basically just laughed out of the room and then out of the scientific community. And I guess, honestly, that's better than some of the big thinkers throughout history that were straight up killed or tortured or forced not to talk about at the easiest, forced not to talk about the world, how they thought the world worked, or trying to convince people that the world worked differently than they thought. We've come a long way with, at least in the United States and a lot of the world, we've come a long way with people not just outright getting killed for being like, hey, I think the world works this way. No, you're a demon. We'll hang you in the streets. That used to be how it was. Like, if you went against the scientific hypotheses or the scientific way of the church of your country, you were probably getting killed, or at the very least, you were getting shunned or ostracized in some way. But anyway, flash forward to modern plant science, and most of Albert Bernard Frank's hypotheses have been demonstrated and proven to be true. Time has a really funny way of revealing the true nature of things. If you let enough time pass, you can, not always, but a lot of times, if you let enough time pass, you can tell whether or not someone was correct or incorrect about something, especially in the scientific community. And these connections in the soil between this fungus and between tree roots and between the roots of other plants, they're called mycorrhizal associations. And these associations aren't just exclusive to forests. They exist in almost every ecosystem. Most plants, upward of 90%, are connected to a mycorrhizal network that is communicating with other plants. It's like the internet. However, it's way more complex than the way the internet works. There's a lot more going on behind the scenes. And so I'm going to take some time to kind of break down how the mycorrhizal networks actually work just a little bit. Mycorrhiza are fungus that exist symbiotically within the root networks of plants. And like I said earlier, I'm going to kind of focus on how they interact with tree roots, because we could talk about how they interact with every species of plant on Earth, but there wouldn't be enough time. I'd probably be dead before I could do that. So we're going to focus on how they specifically interact with trees and tree root systems. The most common mycorrhiza are called arbuscula mycorrhiza, which is named for the Latin word arbuscule, which means little tree. So this fungus, this mycorrhiza, forms among the roots of the trees, and they have these threads that shoot out from them and penetrate the root cells of the trees and form tiny structures inside of them. This is how the fungus interact with the trees and share resources with them. There's also a different type of mycorrhiza. There's two different types, the arbuscula mycorrhiza, and then we have the ectomycorrhiza. And the ectomycorrhiza works in a very similar way, but instead of sprouting threads into the tree root cells, it actually grows around the roots and makes this sheath that grows between the cells of the tree roots to exchange nutrients and information. It's like, think of it kind of like how car engines work. They all move a car and they all have very similar parts that are all kind of doing similar things. I'm talking about fossil fuel combustion engines, not necessarily electric vehicles, but think about combustion engines. They all have similar parts and they all function differently between makes and models, but they all, at the end of the day, they kind of do the same thing. That's what these two mycorrhizal networks do. They talk to the tree root systems, exchange nutrients. They're just a little different in the way that they operate. So how are these relationships actually working? I've said that they're symbiotic, but haven't really got into the nuts and bolts of it. The mycorrhiza, the fungus that is communicating with the tree roots, it picks up moisture and nutrients from the soil. It picks up phosphorus, nitrogen, carbon, and all this different stuff. And they pick this stuff up and transfer it into their host root systems, into the root systems that they're connected to. And in return, the trees give the fungus a percentage of their photosynthate, which are basically the sugars that they produce from photosynthesis, the energy that they produce and the sugars they produce. This is how they communicate. The trees tell the fungus what nutrients they need, what nutrients they're low on, and the fungus adapts and harvests more of that specific thing for the trees. And the trees are like, okay, cool, tight. Thanks for more of these nutrients we need. Here's some more sugar that we made from the sunlight. Keep these nutrients coming, and we'll keep this balance going, and we'll keep this trade going between us. This relationship of fungus and trees is the backbone of how all forests on Earth work. Without this relationship, there would be no forests, there would be no humans. Life on Earth would be very different, and it would look much more simple and much more, I don't necessarily mean simple in a good way, but it would be way less complex. There would be way less going on biologically on Earth had this relationship between these networks never been made. So now that we understand that the fungus is communicating with the trees, we can get back to how the trees are communicating with each other and how they are talking with each other. There was a study done in the 1980s where 2 pine trees were planted next to each other inside of a box in a lab. Both trees' roots were inoculated with a mycorrhizal fungus to establish a connection between the 2 trees via the fungus. Then they tagged the sugar that was generated via photosynthesis in one of the trees with radioactive carbon. Then the scientists placed a photographic film over the box that the trees were growing in to see where the radioactive carbon that had attached itself to the first tree's sugar would travel. And they watched as that radioactive carbon moved from tree 1 through the roots and mycorrhizal network into tree 2, through the roots that connected them. And this experiment changed the plant science community in a really, really big way, because it was the first time that they could see and visibly just prove in a real way that this was happening. These trees were exchanging resources. We have evidence. We have proof now. This was really the first time that scientists started looking seriously at the way plants communicated and shared resources. Before this, trees were pretty much known to evolve by competition, not cooperation. Shaded trees die. Strong root systems get the most water. The tallest trees get the most sunlight. It all, before this point, looked like these trees were coexisting, cohabitating, but it was still a survival of the fittest scenario. The biggest, strongest, fastest tree was going to do better than the other trees. That's the way we used to think. Not we. That's the way plant scientists and humanity used to perceive how trees and forests worked competitively up until this point, up until this experiment where there was empirical evidence to say and to suggest and say they're cooperating, they're talking, they're communicating, they're sharing. Flash forward out of the 1980s, there was another scientist that conducted an experiment between a birch tree and a fir tree. 2 different species of trees that often grow together in forests. She did the same thing with radioactive isotopes on the birch tree so that there would be something to monitor. Then she took another isotope and put it into the fir tree. So now we have 2 different species of trees planted next to each other with different isotopes implanted into them. She did this, then covered the fir tree with a shade tent, which reduced the amount of photosynthesis it could do. Her thought was, if the 2 trees were linked in a mycorrhizal network cooperating, the unshaded birch tree would send the now shaded fir tree some of its resources, which were monitored by the isotopes placed in the trees. Not only did she find that the birch tree sent nutrients to the shaded fir tree, the more shade the fir tree had, the more that they covered it up, the more resources the birch tree sent. This is like plant compassion. It's one tree looking at another tree, talking to another tree through the mycorrhizal network and saying, "Oh, you need something? I got you. Well, we're in this thing together." This is how we can learn from the trees. This is how we can grow from their communication and from their growth through their cooperative efforts to make sure that the other trees around them are thriving. After doing more experiments, scientists found that it isn't just energy from photosynthesis that trees share, but other resources like nitrogen as well. And all of this is thanks to the mycorrhizal networks. They're the reason that all of this exists. They're the technology that glues together the communication between the root systems. And even beyond what the trees are sharing, it's not just resources. Trees produce chemicals that warn other trees when they are being damaged by insect infestations or disease or pathogens or even human activity. They send signals through the network and say, "Yo, look out for this. This is what I'm experiencing. It's coming your way. Be prepared. Do what you can do to shield yourself or protect yourself from these threats that are coming down your way." And there's this other experiment that got done that kind of parallels this thought with tomato plants. And I know I've been mostly, like I said, I know I've been mostly talking about trees, but the mycorrhizal fungal network, it exists everywhere on Earth. All of the plants you see are over 90% likely to have a mycorrhizal network happening among them. It's usually the plants that are just isolated or plants that are like, I'm out here growing and I'm chilling and I'm doing my own thing, that aren't connected to the mycorrhizal network. But even they are statistically probably connected to one. But anyway, this tomato plant experiment, scientists took some tomato plants that were all growing near each other and infested some of them with leaf-eating caterpillars. The healthy neighbors of the infested plants activated defense enzymes that helped them reduce damage from the caterpillars. They fared better, and caterpillars eating the plants that produced the enzymes didn't grow as large. So their communication from an infested plant to a non-infested plant allowed the non-infested plant to thrive under the circumstances because it got a warning. It got a chemical signal shot through the mycorrhizal network to alert it. There's danger. Be prepared. All of these experiments can show us that trees and plants in general aren't operating in an isolated context, but rather they are cooperating and communicating for a mutual benefit. There's a lot of research going on now that suggests that scientists that had competition among trees wrong this whole time. For instance, a tree dies in a forest. Many of the trees will scramble to get to the gap in the tree canopy. And before we thought they do this because they want to get more sun, they want to get more energy, right? But maybe not. Maybe the trees that are scrambling to take up that new spot aren't doing it for selfish reasons. Maybe they're doing it to protect the mycorrhizal network, to stop the sun or wind from getting through the gap in the tree's canopy, from harming the fungus below, and also to continue to generate enough photosynthesis to keep the forest thriving. And that more and more as time goes on and more research is done seems to be the way that they function and operate. It's like for years and years and years, we framed the way that we thought plants worked and put them in a box, their behaviors. We just put everything we knew about them in a box. But now scientists they're panning back and they're realizing that that box is looking wrong, that the frame isn't making sense anymore. Like when we thought the earth was flat, or when we thought that germs were curses or demons making us sick, or when we thought the dinosaurs didn't have feathers. We have to keep an open mind when it comes to science and technology And just in general, we can't put things into a box and we can't say, there it is. We've categorized it. We know how it works. We know how it operates. Because then when we begin to build systems upon that thought, and then once we realize that the foundation of the system that we've been building upon is wrong, it disrupts the whole fabric of the thing we created. So we have to remember, it's good to learn new things. It's good to make new definitions, but it's bad when those things aren't flexible. It's bad when we aren't able to continue to learn, and when we are afraid of changing the way that we thought before. We have to stay malleable. We have to look at the bigger picture, and we have to be okay with disrupting the foundations of things that we think we know. And that's going to kind of bring me into this next little segment about trees. There are these trees called mother trees. They're the biggest and oldest trees, and they are hubs of the underground fungal networks, and they hold the most connection to them. They have the most connected nodes to all of the trees. They share their excess carbon, nitrogen, and other resources with the seedlings in the forest as well. A mother tree can be directly connected to hundreds of trees in a forest. And here, I'm going to get a little gloom because I feel like you can't talk about trees and forests without touching on this. But here's the big problem with what we're doing as humans. We're cutting down many of the mother trees. The biggest and oldest trees in the forests are the most valuable. And even if we aren't just chopping down the entire forest, we are going specifically after the mother trees because of their value. And I know this is a very hippie thing to say, like protect the forest, protect the trees, but it's way more intense than that. Like, sure, protect the trees, absolutely, yes, but specifically we should be focusing on protecting the mother trees. New research is telling us that they are the most important when it comes to the survival of forests and the earth itself. We have to find a more sustainable way. We have to find a healthier way to move forward. What we are doing is very dangerous and very stupid, frankly. We need to find a way to specifically be protecting these mother trees because they are the strongest nodes in the forest. They are like the elders of the forest, and it's wild how this is so. It's so intertwined with fantasy. Like you have the tree of knowledge. You have the tree, this elder tree of knowledge that's holding the whole forest together, and it's literally like that. It's not even fantasy. I wish the trees could uproot themselves like the Ents in Tolkien's world and fight back. That would be ideal if they could just protect the mother trees and be like, you can't have these humans. These are our elders. We need them to survive, and they are the most important to us. But pulling it back, it's not as bleak as I'm making it sound. With all of this new research and campaigns to protect forests now more than ever, and now all the knowledge we have about the mycorrhizal networks and the mother trees, a shift can start to happen. We can figure out what a future with less deforestation looks like. And understanding how trees are connected could change the way that trees are logged. Now that we have this mother tree information, we can move forward and hopefully as a species at least avoid cutting them down. We need to respect these networks because they give us so much. They give the environment and all of the ecosystems so much, and we are a part of that. We aren't these separate things that exist outside of these ecosystems. We are a part of the ecosystems. And on another tip, being mindful of the tree networks and the mother trees allows forests to be more resistant to climate change. So as the climate is changing, humans are accelerating that change. If we can be mindful about these tree networks and mother trees, they can be more resistant during this situation, and they can also regenerate faster after natural disasters if we're mindful about how we are logging. And the need for wood isn't going away. I'm not out here saying that it even can or even should. I'm just saying our relationship with trees has to change, and understanding how they work is super important. All right, trees, mycorrhizal networks. Let's get into a segment of the podcast I like to call Let's Ask AI.
Let's ask AI.
My question to AI today was, what do you think life on Earth would look like today if there were never a network of mycorrhiza among trees? And the answer that AI gave me was, what a fascinating ecological thought experiment. The absence of mycorrhizal networks would have dramatically altered the course of terrestrial life evolution. Without mycorrhizal fungi forming partnerships with plants, the initial colonization of land by plants would have been far more challenging. Plants would have struggled to extract sufficient nutrients, particularly phosphorus, from primitive soils. This would likely have resulted in much slower plant evolution and diversification, significantly smaller and less complex plants, as the nutrient limitations would restrict growth. Less developed soil systems, since mycorrhizal fungi are crucial for soil structure and carbon storage. Potentially no large forests as we know them, since trees rely heavily on mycorrhizal networks. Different evolutionary trajectories for insects and animals that depend on plants. The world might resemble something closer to early plant colonization periods, dominated by small, hardy plants similar to mosses and liverworts that can survive with minimal nutrient uptake. Without the rich plant life supported by mycorrhizal networks, the oxygen content in our atmosphere might be lower, and the climate could be dramatically different. The absence of large forests would likely mean many modern animal groups either wouldn't exist or would be radically different. The entire primate lineage, including humans, might never have evolved without the complex forest system supported by mycorrhizal networks. We owe everything to the mycorrhizal networks, to the fungus connecting the trees. I'm going to move on to the last segment of the podcast, a series of fun facts. All of these fun facts have to do with the topic of today's podcast. The first one is, a single teaspoon of healthy soil contains several miles of fungal threads. So that just gives you kind of an idea of how dense these networks are. The next fact is, the largest known fungal network discovered covered about 2,400 acres, which is 965 hectares of land. Our next fact, up to 30% of a tree's total carbon production can be transferred to fungi, which means the mycorrhizal network is getting up to 30% of that carbon production, of that photosynthate production, when it transfers nutrients to the tree roots. That's the trade ratio, up to 30%. So tree is producing 100%, keeping 70, giving 30, and the mycorrhizal networks are giving nutrients from the soil. It's a pretty sick deal for the fungi in the soil. Mycorrhizal networks store about 5 billion tons of carbon globally. That is so much carbon. I thought this next one was pretty cool. I mean, all these have been fun, but this next one I was like, wow. Dying trees can send their remaining resources to neighbors, which means, I don't have to explain this to you, but I just thought that was a really cool and special thing when a tree knows it's dying and it's like, I'm on my way out. Here's everything I have. Here's everything I've collected. Let me give it back to the collective forest because I don't have any use for it. This is the end for me. I just thought that was really poetic. Our next fact is trees can quarantine themselves by cutting off network connections when they're infected. I thought that was a really cool fact too. Like, I'm sick. I'm cutting off for now. If I die, I don't want the rest of you to die. It just furthers the thought that they are working together, that these plant systems are working together and they want everyone to thrive. And they know that if they infect their brothers and sisters with a disease, that it's just going to wipe everything out. And they don't want that. They want to see everyone thrive. And the last fact is that trees use the network to prepare for seasonal changes and to talk about temperature and light changes. I just thought that was a cool one. Like, once again, playing this game of telephone through the mycorrhizal network, like, temperature's dropping, might be getting close to winter. Maybe we should be doing X, Y, or Z, or, storing our resources to get ready for the winter. They're getting ready for hibernation as well, and they're talking to each other about it. This is such a beautiful planet, and understanding how it and its inhabitants communicate is so important. Continuing to think beyond the constraints of what we think we know and what we've been taught is vitally important to survival and progress. So I invite you today to go find a tree and just thank it. And then thank the fungus in the ground. There are a lot of amazing things happening around us, beneath us, for us, and with us. Remember to check on your mental health, and remember to check on the mental health of your loved ones. I'll see you next time. Bye.
Thoughts. Analog thoughts.
Analog thoughts.
Analog